Okay, in this video I wanted to show some of the differences between a Python 3 class and a Python 3 dictionary. Okay, we can sort of use dictionaries to sort of mimic the feel of a class, but it's not quite the same, and I'm going to point out some of the differences. Okay, so on my desktop here I have a file named basket_class.py and then basket_dict for dictionary. Okay. And what we're going to do is we're going to try to mimic the behavior of a class-like object in both of these. One as an actual class and one as a dictionary. All right, so let's get started. Let's start on the class first. We're going to make baskets, and the basket, it's going to be, we'll call it a fruit basket. All right, so the first thing we need to do is define the constructor or initializer, and remember all of the methods on a class take the self parameter, and in here we're going to have two things. We're going to have self.contains, so I'm creating a property on this object called contains, and I'm going to set that equal to something. So we'll start out with apples, and then self.count is going to be the number of items in this fruit basket, right? And so we'll say that starts out at 10. Okay. So down here we have our if name equals main. This basically only runs if we run this file directly. Everything under this if statement will not run if we import the file instead of running it directly. Okay. So this is kind of used to test out our work for this particular file. We can run little tests in here that won't be used when we import the file in another project. Okay, so what we want to do here is we're going to have a fruit basket A, and that's just a variable name. I'm going to set that equal to the instantiation of our fruit basket class. Okay, so fruit basket is the name of the class, and so that's what I'm typing here, and then left and right parentheses instantiates an object. Okay, I don't pass in any arguments because none are required. By default, the self argument in a class is automatically supplied. If I supplied any other arguments here, they would correspond to the parameters defined up here, which we'll do that in a second. So I have fruit basket A, and I can print FB A dot contains, and I can print FBA dot count. Okay, so this is what's called accessing values, or in a class these are called attributes. Attributes are anything that are attached to a Python 3 class. To access these items we use the dot operator. Okay, now this is different than how we access items on a dictionary. Okay, so all this is doing is creating one fruit basket. This should print out apples because that's the attribute contains is set equal to apples, and then it should print out the attribute count, which is set to 10 by our initializer. Okay, so let's run this Python 3 and then basket class. All right, and there we have apples 10. Now what we want to do now is go over to a dictionary and try to create similar functionality. All right, so to do that, the first thing we could think of, right, is we create a dictionary A, and we can just create a dictionary here, and we could say contains, right, and we have to use quotes here, and what does it contain? Apples, and then we can say count. And what is the count? We can say that's 10. Right? And then down here, we access values. We don't access attributes. They're called values in a dictionary. A dictionary is a key value store. So the things on the left here are the keys, and the things on the right are the value. So to access those values, I can print, and I can specify the variable in which the dictionary is stored, so that's DIA. And to access in a class I use a dot operator, but in a dictionary we have to use square brackets and then specify the key. So here it's contains, and then we want to print dictionary A, and then the count. All right. So if we run this, Python 3 basket dictionary version, we get the same stuff, right? So why is a class, why might a class be considered better? Okay, one thing is we can create multiple instances of this class. So FBA, I might want to create a fruit bucket or a fruit basket B that has something that starts with a B in it. And I might want to say fruit basket and pass in arguments here that will correspond to the parameters of this initializer function. So I might want to pass in what it contains, bananas, and then maybe a count, and I can say the count for that is 13. Okay, so I'm passing in two arguments here, but I do not have any parameters up here in this initializer function that correspond, so I have to add those. So what I can say is I can say contains, and by default, if I don't include it, it will be apples, and then count, and by default, if I don't include it as an argument, it will be 10. Okay, and then I can change this to contains, and this to count. Okay, so we see in this first one we are not providing any arguments. So the contains parameter holds the default value, and since there's no count argument provided here, the count parameter holds the default value of 10. So then we set self.contains equal to whatever the contains parameter holds, and then self.count equal to whatever the count parameter holds. So both of these cases, this one just uses the defaults. Here we're providing bananas, so the contains parameter is actually set equal to the value of the argument that we're passing in. Our count parameter in this case is going to be set equal to 13 because we're passing in the argument 13. Okay, so in this case we've made two fruit baskets, right? And I might want to print those out too. So I can just copy and paste this, get the indentation right. And instead of FBA, I'm going to use FBB because this is the fruit basket of items that start with a B. Okay, and I might actually move this down here. So we'll keep all the individual fruit basket stuff together. So we have FBA, and then we print out the FBA stuff. And we could keep doing this. We could add cranberries, for example. Cranberries. And those are small, so maybe there's 144. The name of this variable we're going to say is FBC for cranberries. So a fruit basket filled with cranberries. So when we print these out, we will see three different baskets of stuff. Basket, class. Okay, and that's nice. And then one other thing we can do with the class is we can define what happens if we pass this object, an instance of this object, into the length function that we use. We use the length function all the time for lists and dictionaries and things like that, and strings to determine how many characters or how many elements are in that item. So length here, when used on this item, we can specify what to return. So length in this case, we might want to say that the length is really self.count. Okay, and that allows us to do something like this. Fruit basket A, we want to get the length of that. So instead of using this property, we can just use the length function of our basket. Right, and we can do that down here. And we'll just copy and paste that and move it down, and the length of FBC. So really these two lines should be printing out the same thing, but the trick here is that we're using the length function just like we would for any other data structure that has a length, like strings or arrays or dictionaries. So that's kind of nice that we can do that in a class. All right, so we see that's how that's done. Now, if we compare everything we've done so far to a dictionary, right now we just created a dictionary literal. So if we wanted another dictionary like DIB, we would have to create a whole nother dictionary, the keys and everything. It's rather tedious, right? I could say contains, right, and then I could say bananas, right? And this gets tedious. So maybe instead we can have a function that creates one of these dictionaries. All right, so let's define a function that's going to be like our initializer. We're going to compare this to our initializer. We're going to say the name of the function is create basket. All right, and this function we're going to need to add what it contains, and by default we'll say apples, and the count, and by default we'll say 10. All right. Now what we want to do is create a dictionary, and that dictionary is going to have contains method, or a contains property, a key anyway, and then that's going to be set equal to the value of what's held in the parameter contains. Okay, so if nothing's provided, it will be apples. Then we add a key count, and the value of this key is going to be equal to whatever's stored in the parameter count. Okay, then we want to just simply return this dictionary. Okay, so this is going to be equivalent to our initializer or our constructor in the class version. All right, so what we can do is we can get rid of this, and instead we're going to create a dictionary here, di_a. So this is the dictionary version of a basket of fruit that starts with A, and we're going to say create basket, and we can just use the default values like we did before. Okay, so this is going to create a default basket, and we have these two items in it. Python 3 basket, and this is the dictionary version. Okay, contains, misspelled something. Yep, contains. There we go. Okay, so this is similar. Now we can do, what we can do now is print out multiple, we can create multiple of these baskets, right? Which is kind of the idea in our class implementation. So now I can make a different basket. This is create basket. And here I can pass in bananas and a number of bananas that I have in that basket. And then I can just copy and paste this and change the variable from DIA to DIB. And then I can copy all of this, and we can do DIC, which is cranberries. Okay, so far the main differences is access. How do you access the items? In this dictionary we use square brackets and then the key, right? Whereas in the class implementation we use the variable name and then the dot operator to access the attribute. But otherwise, it's pretty similar what we're trying to do with both of these data structures. Okay, these are called design patterns. How you design a structure to hold your data. Okay, it's just a pattern we use in coding. There's lots and lots of different design patterns. Okay, so we run this again, and now we see, just like the other one, we have apples 10, bananas 10, cranberries 144, right? One thing we don't have is that length functionality. And we can't get that. There's no easy way to get that. What we can do, though, is we can create a length function separately. And as a parameter, we can pass in some dictionary. Okay? And then what we can do is return the count of that dictionary. So whatever we pass in, we can say di.count. Okay, so this is similar to using the len function but it's not quite the same. Okay, we'll see that down here. So to use this, I have to say print, and I want to call the length function and pass in the dictionary that I want to use, which is DIA. And then here, this is DIB. And I'll make a copy of that and move it down. And this is DIC. Okay, so I'm just using this length function that I created up here. It's really simple. It has no attribute. Oh, I used the dot operator. So this is a dictionary, which means we have to use the square brackets and key value access. My apologies. So that is one of the distinctions, one of the primary distinctions between a dictionary and a class. The attributes of a class, you use the dot operator to access them, and then the values of a dictionary, you have to use square brackets and then the key. Okay. So I get confused with that because in JavaScript you can use both ways to access in both things, but we're in Python land here, so that's important. All right, so we run this. Okay, and so this is the same output that we had up here for the class version, so that's kind of nice. One thing that's not nice about this, though, is we have two separate functions here, whereas in the class, everything is tied into this one fruit basket class. Okay, so one thing we can do is we can add to this dictionary. I can add functions into the dictionary. I can actually say I want a property on this dictionary, or a value, and I'm going to say this is length, len, and I'm going to set that equal to the length function that I've already defined up there. Oops, I spelled it there. Okay, so what this is doing is I'm attaching to this dictionary this function, and you can access it with the key length. So down here, now we're going to have sort of a similar access as we do to a class. Okay, so I have dictionary A, and I want to access the length value. So length is the key, and it's associated with some value. This is going to return whatever I set as the value here, which is the length function. Okay, so this thing here returns the function itself, and then the left and right parentheses with this argument is calling that function with the dictionary, the same dictionary as the argument. So here, this di is going to be, the value is going to be the argument dia. So this parameter di is going to hold whatever was held in this variable. Okay, so this is similar to attaching methods to a class, except we're using a dictionary. So this is a little bit more complicated. You probably won't see this style done very often, because usually if you have something like this in Python, it's time to move to a class. Okay, but it is possible in Python, and I want to show you the similarities, basically kind of what classes are doing under the hood. They're doing similar things that you can do with dictionaries. They're just making the syntax a little bit easier to understand. Okay, so for each one of these, I can change it to instead of this, I want to call dib, right? And I want to access the length property, which should be a function. So if it's a function, I need to call it with left and right parentheses, and it takes one parameter, and that's a dictionary. What dictionary? dib, because I want the length of that particular dictionary. All right, and to save time, I'll just copy and paste this down here and change the B's to C's. Okay, and we'll remove that one. Okay, so we should see, if I did this right, we should see no difference, right? But the way we're accessing the length value on this dictionary is similar to adding a method on a class. Okay, but there is no good way for us to add the functionality to allow us to use the len function. All we can do is add a length property. That would be kind of like over here we could add a function called define length, and we could return self.count. Right, and instead of down here calling the length function, we could call FBA.length. Right? So this should be the same thing. So this is unique to classes. You can't do that with dictionaries. So that's kind of handy. Any of the built-in functions in Python, you can override the functionality with within a class. All right, so we can say Python 3. Right. So we see that didn't change the value, but it changed how we accessed it. We attached a method. Okay. So as you can see, as we build these items, printing this all out, we're doing it over and over and over. So this is a good time to add maybe a print function inside of the class. Okay, so we're going to do that for the class and for the dictionary. So let's define a print. We're going to call this print me. The first parameter should be self. And what I'm going to do is print out a formatted string. And I'm going to say basket of, and then get the count, self.count. Or I could say self.length and call it like a function. That will give me the same number. Or, in this case, I could say the length of self. So any of those three would give me the same value. Two of them are functions, and one of them is a function that's not attached to this object. Okay. Self.length is attached to self. This length function is a global function available in all Python scopes. Okay, so that's the difference there. So let's do self.length. We'll use that function. It's the function that is attached to the object. So it's a basket of some number of, and then self.contains. Oh, we don't need the of there. So this is a basket of, and for the default case it'll be 10 and then apples, period. All right. Then for each one of these, we can remove all these print statements, and we can say FBA dot printing. And then we'll paste that down here and change it to FBB and FBC. Okay, so notice this print me function is attached to our object, and that's nice. It's built right in. Okay, and when I call this dot print me, the object itself is being passed in as the first parameter self. So whatever this object in this class that I've instantiated, whenever I call an instance method on it, itself is automatically included. Python does that for you automatically. I don't have to do anything like this, right? When we look at the dictionary version, I will have to do something like that. So I'm repeating myself. So classes give us this nice feature that don't force us to repeat ourselves so often. All right, so we'll print this one out and see how it looks. Python 3 basket class, basket of 10 apples, 13 bananas, and 144 cranberries. So that's nice. So we've got a couple different methods on here, and this has cleaned this up a little bit. All right, so let's go back to our dictionary version and see what that would look like. We're going to try to make a print me function on there. Okay, so first I have to make the function, but then if I want it to be actually attached to my dictionary object in the init function, or in my create basket, I have to actually include it in here, right? So let's first define the function. Print basket, and it's going to take a basket dictionary. Okay, so we're going to want to make sure that this dictionary is a basket, right? Theoretically, it can just take any dictionary. So that's another nice thing about the class. We can use the built-in type function to determine what type of object we're dealing with. Here, if I just say type of dictionary, it's just gonna say it's a dictionary. That's the type of object that I'm dealing with. Okay. So I want to print this basket, and I need a basket dictionary. and I'm basically going to do the same thing. I'm going to print a formatted string, and this is a basket of, and then I can say basket dictionary. Now I can't use double quotes to access my value because I'm inside of a formatted string. Okay, so I have to use square brackets, and I'll have to use single quotes, and I can say I want to access the length property, right? So that's going to be accessing this length key, which is going to return this length value, which is just this function. Okay, so I want to call the function left and right parentheses, but this function takes in a dictionary. Okay, so we're going to have to pass in the dictionary. What dictionary do I want to pass in? Well, whatever one I received in this parameter. Okay, so this whole thing, this is starting to look a little bit ugly, right? It's a little bit complicated. Basket, dict, and then what is the value we'd like to retrieve? We get the length, and then that's a function, and instead of just calling left and right parentheses, we still have to pass in our dictionary. So compare this, if we go back to basket class, compare that to here. All we did was self.length. We didn't have to pass anything here, right? We didn't have to use square brackets and quotes to access the length property. So when dealing with objects, it's always just a little bit nicer. You don't have to access every single thing with square brackets and quotes. And additionally, you don't have to pass in the object you're talking about with every function call. All right? But this is essentially the same thing. So that will give us the count. So we have a basket of some length, right? So this will be 10 apples for the first one. And then we have a space, and then we have to say, well, we have the basket dictionary, and we want to access, and again, since I'm inside of a formatted string here, I can't use double quotes, I have to use single quotes. So I'm going to access an item inside of the basket dictionary. This is contains. What does it contain? All right, and then afterwards, inside of the string, I add a period at the very end. So everything in the curly brackets is basically Python. It's a Python expression that's going to return a value. So this is going to return some value, and then the curly brackets say whatever that value is, inject it into the string. And then we do the same thing. So this is going to be the length injected into the string, so basket of 10, and it'll convert it to a string automatically. And then here we have the type. And then the curly brackets say, since this is a formatted string, inject that into the string. Okay, so this should be apples for the first one. And for each one of these now, we can just call print basket instead. Then we can add this function into our dictionary. So we can call this print me like we did on the class. So this is the print me method, essentially. This is sort of how classes work. Right? So I'm attaching a function onto my dictionary, and I'm calling it print me, and the value of that is my print basket function that I've made up here. It takes one parameter, so I always have to pass in a parameter, but it's attached to my dictionary. Okay, so now down here we've created our dictionaries. I can replace all of these items with dia, and I want to access the print me function. And it's a function, and I can just call left and right parentheses. But in a class, that's all I'd need to do, because the class automatically passes in the dictionary for you. But here, see how these all take a dictionary? I have to pass in one of those dictionaries. What dictionary do I want to pass in? Well, my instance, my particular object. Okay, so I create a basket and I pass that in. This is why that self parameter is there, because Python does this for you automatically, so you don't have to do it every single time. Okay, and if we go down, we can copy and paste this and remove all of these and replace dia with dib, and do that for dic as well. All right, now if we run this, Python 3 basket dictionary, basket basket DI. So that's my fault. I put the wrong parameter name there. Okay, so this is a basket dictionary. Let me run that again. And see, we've basically mimicked the behavior of the basket class, right? So there's the class version, and there's the dictionary version. All right. Now, the dictionary version is still not quite as nice, right? There's a few things we don't have. We don't have access to using the global length function, the len function. And if I were to import this into another project, I'd be importing several things. I'd be importing these three functions, basically, instead of just one object. Okay, so with a class, I can just import that one object, and everything's attached to it. But essentially, I've mimicked the functionality. It's a little bit more verbose, and it's a little bit harder to work with as a dictionary. But this is the exact concept of what a class is. The primary difference is how you access the data. So when I want to access the print me function, I have to use square brackets and then a string value for the key. Whereas the print me function in a class, if we go over here, is just the object and then dot print me. And that returns the function, right? And then to call the function, I use left and right parentheses. Okay, so this is just to show you that there's really not a whole lot of difference between a dictionary and a class, other than some syntax, and one is a little bit nicer to use. Okay, and then also one of the most important things is let's look at the type of this class. So we're going to print out what is the type of one of these objects. This can be very useful if you have a function that can take a lot of different objects. So we have a basket of fruit, but what if we have a basket of vegetables or a basket of all these other items? You might want to do something different if the class is different, right? It might have different properties. So with type, if I run the class version again, I can see that this is a fruit basket. And I could say type is fruit basket. Right? So does this type, is that the same? Is that one of these? Fruit basket, which is the class? It is true. So I can tell exactly what kind of object I'm dealing with. Okay, then that's something we can't do with the dictionary versions. If I say print type of dictionary, this will be the C dictionary. If I print that out and we go back up to the dictionary version, I'm running the dictionary version now, we see it just says it's a class dictionary. But I could put anything in here, and that doesn't prove. I could just put a dictionary literal in here, apples, which this is not even close to what we should have in our dictionary up here. We have contains, count, length, and print me. But this is still going to read as type dictionary. So there's no good way to figure out the type of data in a dictionary. It's a little bit more generic. Now there are things you could do. You could run a function to iterate over all the properties and make sure the properties are the same, but it's complicated. It's much easier and much nicer to use the type function and use a class. Okay, so those are some of the most basic and primary differences between a class and a dictionary, but it is important to know that you can kind of mimic that behavior with a dictionary. The class just gives you some nicer tools to do that, some nicer syntax and a few extra tools. But all of this could theoretically be done with just a dictionary if you wanted to. Okay, so that should conclude this introductory comparison between classes and dictionaries. So hopefully that helped you sort out some of the differences.